Okay, it looks like we started. Alexander, hi. My name is Dima. I'm in Israel, working at Microsoft. Going to do a mock interview with you. Can you tell me about yourself a little bit?
My name is Alex. I'm from Moscow. I'm Python developer. I think we can start.
Okay, cool.
If it's enough.
No? Yeah, it's enough. As you wish. No push at all. So I started recording. Now I should also share. Do you already joined to document? Yeah, I see you. Okay, cool. Let me share my screen. Share screen. Desktop. Share. Cool. Okay. Let's close this. 1 second. Yeah, I think we can start. So, do you want me to start, or do you want to start?
I can start.
Okay, cool. You mean you will be interviewer? Or you want to solve first? Okay, cool.
Solve
I got it. So I wanted you to ask. I copied this question from Geeks for Geeks. I will send you a link after our interview. I want you to create least recently used cache data structure. So it will be like, I will copy requirements from it. So it will be clear for you to understand the question. Yeah, I think you can read it and we will continue. Do you want me to give you example?
Yeah.
Okay, cool. So least recently used cache. For example, we are setting several values. Let's say A1. How's better? Yeah, let's say A1. A is a key, 1 is a value, B 2, and C 3. So you have 3 values in a cache. And as it least recently used, it means if I want to, in this case, I put A1, B2, and C3. C3 was last one. So it means it will be start of the cache. And let's say we have capacity 3. So it means if I adding D, also let it be 3, it means A will be deleted because capacity is 3. This is clear? Okay, cool. Also, we have get operation. And when you do get operation, it means for example, if I want to do now get C, it should return 3. And your cache will be looks like C3 will be first value, then B2, and then then D3, and then B2. Got it? So when you do get, it means you take the value and put it in the start. So if, for example, you have capacity 3, let's say like that. So if I want to do B, it should return 2. And then I want to, let's say, adding F2. So your result will be B2 will be the first one. So I should be very. So we do B2. So this is our start. Start is here. We should be 2, so it means we have B2 coming to start. This 3 was first, so it becomes second one, and C3 is the last one. And then I put F2, so it will be D3, B2, and F2, and C will be removed because it was last one operated.
Okay. Let's start. Can you give me permission to edit document?
Did I have permissions? Did you send me Word? 1 second. Get link. Weird. Okay. Editors can change permissions and share. Okay, let's do like that. I will. Can you send me the mail? Your mail. So I will add you. Do you have Gmail mail? Email?
Yep.
Send me please. So I will copy it in a Zoom meeting and I will add you as an owner.
In Zoom chat.
Yep. Sent.
Yep.
Okay, cool.
Okay. We need to initialize class with capacity, yes?
Yeah. So you're going to use Python, right? Okay, cool.
Yep, Python.
What are you thinking about?
I think about using default Python data structures. Like we can use dict for store k value pairs and use list to check order and move elements on get or set.
Okay.
Mhm. Order. Use dict. So get method get get key. We can check value. It's this method return the value of the key if it exists, and if not, return -1.
Okay.
So if -1, we don't need to change order. If value so if we have key value in our cache, we need to move this key on the top.
In a cache, are you going to have exact value, right? So it will give you one time to get right value and return it. So it will be in our, for example, in our example, let's say string will be our key and integer will be value, so it will contain integers, right?
Yep.
Okay, cool.
If we have value, we need to move this key on the top of the order. So we need to. I can use brute force to find the index of the key in our order list. For example, for key and order.
So you're going to iterate through each. Will be will it be optimal? Or we can, let's say I understand this approach. So we just find it, remove it, and return it. But can we do better? Let's think about it. Actually, what is time complexity will be in case if we are going to look every time when we are getting key?
Every time, OM.
Okay. Okay, good.
If every time will be iterate for order, it will go in, but
capacity, I mean.
Yeah.
Okay. So I think about it together. We are discussed. So OOFN is our brute force solution. It means we are going to take it somehow with O of 1. So this will be the best. In what? How can we find the value in O1?
Oh. Now I just see only brute force solution, but I know that it's not optimal.
Okay, I will give you a tip. You already have cache, and it will return you a value. What if it will return you like not only value, but actual object that contains k in value? So, and you will store not only values of it. So you in your cache you will contain like new class, for example, not, and it will contain k and value. And your order also will be contained in nodes. So you can take the position in all of one time.
So you need to make we get key value, key value. But
will it help actually? I mean, what I no, I mean
now I don't fix so because I can see full solution. I can make a brute force solution and try to optimize it.
Okay, if you insist, let's do like that. Just keep in mind my idea about node. Let's implement brute force, and then we will continue.
So okay. If we find k index, we can
Okay.
Yeah, I know it's not a better solution. Right.
What did you say? Sorry.
I know, but it's not a better solution. But I just can.
As you said, yeah, it's brute force, but I think it's okay for now to implement it. Try to implement it, and then we will try to understand how can we do better.
will be our get method, and method will get key. We need to get first element. Okay. If we have this cache and add new value, for example, this. If I want to add f, it will be c d f. Yep.
If you.
That's right. If we have this cache, this b c d.
Okay.
And
yeah.
And edit f to this, we can have c d f.
Right. Yeah.
Okay. Okay. We need to get first. Order. Remove first key from our order, and then okay, and just edit self order.
So you're always taking first element, right? Remove it from dictionary and append new.
If only to, in this case, we need to remove key and remove it from cache. Yeah. If we have
another case. Okay. Yeah. Okay. But what will be if, for example, you are adding new value, but with the same key? So, for example, you have C1, A1, B1, yeah. C1, and you adding again A2. Or B2, let's say B2.
We need to change order in this case. We need to check if key exists in cache and just change order. Yes.
Yeah.
If yeah. So. If we have key, just update self. So, and then again, we need to up to top. Yep. B.
Yeah, it should be
if
on
we
top.
have this
Yeah.
cache, we add B2. It will be A1. Yep.
Yeah.
Okay. We just can copy this for solution, and I will think about a tip about nodes. So
just for me, this one K node in self cache, it also will iterate. No, it's,
it will be iterate through the key of the cache.
So it's also of capacity. Okay.
But we can use this for this. We can use self-get.
Okay, yeah.
It will be better, but we still have brute force here. So
I think you also can remove this one. But yeah, no matter. Continue.
So you tip about node. So I think I can't implement this by nodes.
Okay, we have 5 minutes. Let me give another advice. You use list, but what if you will use not just list that gives your Python, but use like node that have, for example, next and previous one. So you have
double linked list.
Double linked list, but I'm not sure. Maybe you in Python there is data structure that can use like that, but I want you to have like nodes, and so you will operate like with how to say. So you will have like head, you have own list, own implemented node list. So it will help you to get exact value, and you can operate with previous value, next value. You also can track last value and head value, head object. So it can help you. I don't ask you, because we have 5 minutes left, I don't ask you to implement it in a code, but I want you to create the structure and describe me how can you use it. If you get my hit, of course.
Yeah, we just keep key here. And 2 pointers to the previous node, the equal node, and next. I got your point, but if we will have head and tail,
So using hash, you can access exact value that you want to get or remove. And now you just need to operate with it, like to get it and remove it from its current position and put in the start or remove it at all.
I probably understand. We need to we can add to cache by k, and it will be store our node. That
okay.
But we need head and tail. I understand this solution, but I can't implement this. So, yeah, I understand that we can use these nodes, and when we set new node, we can change the order to here.
Can you explain me on this algorithm on this example? So we have what you actually need to do it.
For example, we add B2. We just get this node. For example, we use so we remove this node from our linked list. And so if we have head pointer, we just do head our B node and our head next. Something like this. If they add new B value.
Can be any problem here?
Yeah, power capacity.
Yeah, agree capacity. What else? I want you to catch edge cases here.
If we have this node.
Yeah, if we have, yeah. And one else still.
If we set new node and but it's, for example, if we add new node like E1, yep. If E1.
Okay,
we need to store somewhere our length of our linked list to check it when we set new value and remove it.
Okay, never mind. I just want you to say that you see here you use pref and then next. If for example your B is first element, pref will be null, so we get here null pointer. But never mind. It's a little bit tricky here because it's not real. So we're trying to.
Yeah. Every time we need to check the next value. Yeah.
So there is lots of edge cases with moving lots of stuff. Yeah, but okay, never mind. Let's leave feedback on the end on the interview, and we'll start with my turn. What do you think?
Okay. Yep, we can.
Let's go to the next page. Yeah, I'm ready.
I prepared description. With examples.
Okay. N-bit gray-code sequence is a sequence of 2 n integers where every integer is in inclusive range. Okay, the first integer is 0. An integer appears no more than once in the sequence. The binary representation of every pair of integer differs by exactly 1 bit. Okay. And the binary representation of the first and last integers differs by exactly 1 bit. Give an integer and return any valid n-bit gray code sequence. Okay, let's see example. Input 2, we have 00010. Return any valid n-bit gray. What does it mean, n-bit gray?
N-bit gray, I think it's just the name of this code. You need to return the sequence of two n integers. Well, so if we have input 2.
Okay, got it. So input will be so we want to implement function with input n and return any possible sequence of this.
It's just one sequence.
Yeah, the one sequence. It's also possible. I don't know. Use this one, so it can be like 2. Let's write it here. 2 0 0 2 0 2 3 1 also will be valid, right?
No. Just this sequence will be valid because we need to, the first integer is 0 and the first and last integers differs by exactly 1 bit. So yeah, 0 here and here we have 2.
Yeah, but you see 1 and 2 have same amount of bits. So if I will switch them, it will be the same. All neighbors will be with 1 differ, and also first one and last one. In our case, it will be 1.
Yeah, I understand. We can try. Yeah.
Okay, cool. Okay. So first of all, let's think. Bit operations. We know the size, so I mean we know the integer n, so we can calculate how many bits, how many values we are going to have. We have 4 values. And n will be always more than
from 1,
right?
Yeah, from 1. Yeah.
Okay. And what is the maximum value?
16.
16?
Yep, 16.
Okay. So okay, right. So it's integer, just integer. So it can have maximum, how to say, maximum bits will be 32. How can we solve it? So I think let's have a little bit more examples. Probably I will can get it from example in case, let's say 4. 4 it will be too much, I think. 3. Okay. So it means we have 1, 0, 2, 3, 4, 5, 5. Yeah. Each representation, we already have this one. 3. We also have 4. 4, it will be like 4, like this, and 5 will be like this. And also we need to add zeros. Oh, here 0, 0, 0, 0. Okay. So where we can put it, so we already know this, where we can put this one and this one. We can put it 5 here, right? And also we have 1, so yeah, something like that. Should be like that. Okay, in this case it's true.
I can show you the right order for this case.
Is that what I did? It's not right order. 0, 1, 5, 4, 3, 2. No.
No. It will be 1, 3, 2, 6.
From where we got 7, if we can have only maximum n to n value, so maximum value should be 5. No.
2 power n.
It's power, because you see inclusive range 2n. Okay.
Yeah, range is yes value.
Got it. So it's
sorry.
No problem.
My bad.
We'll figure out. Okay, so let's delete it. So it's powers. So we have 2, 1. Okay. 1, 3, 2, 6, 7, 5, 4. Interesting. Can you give me a tip? How can I, in what way I should think? I'm thinking about sorting and also I'm thinking about bit operation, but still not clear for me.
You can think about bit operation and you can look to order. For example, we have 0, 1, 1, 0, just adding 1 bit, additional bit here. For example, here
got it. Yeah, I got you. So every time we adding bit to not set value. So we know so we have 0, 0. We added 1 bit. If we find in first not set it bit and set it, then we going down. We have 0, 1, finding first not set it bit and set it. Next, we are trying to find it. We didn't find it because we out of our bit range. So it means we need to set first, right? Yeah. So we need to set first as 0. Okay. Let's consider another example. This one. So it remains the same, right? 3, 2. So 6, 7, 5, 4. So 0, 0, 0, 0. 6, it will be 0, 0, 1, 1, 0. 7, 3 ones. 5, 1, 1, 1, 0, 1. Still. and here 100. Okay, if we thinking about set first not set it bit, why we didn't set it here? So we came here. So what if we wanted to continue our algorithm with bits, I would set it as 0, 1, 1, but we already use it. Okay. Now in our algorithm, we even need to use not 3 and 2 here. In our algorithm, we use 1, 1, 1. So probably it's better to copy Let me copy it, so I will operate it. So I'll try to. So we have 0, 0. Okay, and then we can do like that. Then we use 0, 1. Then it's already 0. Let's try to use this. So it will be 4. This one will be 6, still 6. This one is 7. 1, 0, 0. Then okay.
Yeah. This is only one right order. You can.
Yeah. It's still
return like.
So here we found that not fine. We found that we already reached the limit, so we're going to use zeros here. 0, 0, and here. So this is a tricky moment. When to understand that we want to use 5.
Because we
and
have,
what's left.
Have this.
And also it's here, it's 2. So it also will be right. Yeah, 2. Yeah, 2. So it also will be right order. So I need to improve somehow this algorithm. Okay. And we, as I understood, we don't really want to use additional memory, right? We don't use like hash, what we already used. We want to work only with bit operation.
We can, right? In this case, we can have just one array for our results and operate them with this.
Yeah, got it. Interesting.
So I can give you a tip. You don't know. You don't need to change my order, because if you try to change it, it will break all solution.
No, I didn't want to rearrange it. What I did, as we discussed, we want to check. We want to increment bits. So we go here. We have all zeros. Find first. We incrementing it. Did it. Then this is 1. So we currently have 0, 0, 1. So we want to update second bit. Okay, cool. Found bit updated. Here in algorithm that I wanted to implement, and trying to develop. So I found another new not set bit. We set it. Okay, now we reached our bit limits. So it means we are going to make opposite operation, not set bit, but zero it. So we 0 first bit, we 0 second bit, and here in this point we need somehow to understand that we don't need to 0 last bit, but we need to increment again. So okay, got it. So in this case we can even okay, so we can have like a parameter that will tell us what current size we want to use. It will help us. Yeah. So, for example, here first of all we are going to set all our bits. We reach this point. Now we reach this point, and before our size was 3. So our size, let's say max, I don't know, limit. Let's say limit was 3 here. Here we set it as 2. So it means we are going to operate with first 2 bits. We operate with them, so it means we now first bit, now second bit. So as we reach the limit, now we want to do again setting once, but with limit 1, right? It was limit 2. We reached it. Now we want to. No, doesn't work.
Because I think it's not correct order.
Why? Where is what I missed?
Probably think this gray code has just one right order. I'm not sure, but I think so. And if you look up on right order, you can find the solution.
Yeah. You mean okay? Yeah. You're right. I checked my order, but I don't think my order is wrong because I don't see why it's wrong. Do you see it? Because all neighbors has one difference bit.
But
okay, I got your point.
How to implement this?
Yeah, this one is hard to implement, but
yeah,
still the right order. Okay, let's check. Got it. So we are trying to solve it from the solution. Okay. So 1, 3, 2. Okay, we set bits. We set 2 bits. Now we want to. I can't tell. That is still easy. I
can give you one more tip.
I definitely need it.
For example, on the start, you has this array, and you start to from this array. And I can implement some next iteration with this.
So you mean how to add to the next value? So we are going to add bit 1.
Yeah.
Okay, we have 0. We are going to add bit 1, so it will be 0, 0, 1. Then we want to add new bit to the start, right? So it will be 0, 1, 3. Then we can't add bit because we already reached our limit. So what we want to do here? Here we want to. We said we can remove bit from the start, right? So here, what I do, add bit, remove first. So it will be 0, 0, oh, no. 0, 1. I don't know why I write it down, but let's say it will help us. We removed first.
You can just use previous values to get new values, just adding one bit. Every time we use previous values, and
how here we are for how we are getting 3 to 2.
I think my next tip will be so close to solution.
Got it. Okay. So maybe play with mods like. So it goes like that. It goes 0, 1, 3,
1, 0,
then 2, 6, then 7, 5, then 4. No, I don't get it.
So we have 2 values for 1. Okay. We have n and 1, and we have 0 and 1 for this. If we want to get n2, we need to get previous values and then 1 bit to them. So we
are adding
here.
It will be like it's like palindrome. So we are getting for first we adding 1 to the middle. For 2 we adding 1 to the middle for 0.
Yeah.
And when we want to have 3, and it means to 0, 0, 0. No, we want to have 3. So last one will be adding to the end. Okay, got it. Right. Wow, nice. So we're adding bit to the end to the so our size is telling us what bit we are going to add. So
yeah.
And for wow, nice. Wow. Cool. Okay, I think I have 5 minutes. I will try to implement it. Okay, cool. Let's say we want to create get gray-code with integer n, int n. I'm going to implement it in Java. I'm sure I don't have time, but I still try. So let's say public, we are going to return number of integers, so list of integers, int res will be our new int with size 2 powers n, right, -1. Cool. So we are going for still be tricky, even coding. So we are going to iterate it. How are we going to iterate it? For int from 0 to how many this comparing we have. So we have, in case we have 3, we already assume that we already create for 4. We even can do it with recursion function. I'm thinking about is it make sense? Probably not. Probably we can do it with iterative way. Okay. So let's see again. This is no need. Okay. In case of 4, we already here. And every iteration, our array will be rearranged as twice size. Okay.
So you can have array with 0 on the start, with one element, array with one element. So like
Yeah, I agree. It's basically already filled. When we do it like that, when we initialize it like that, it will already have zeros. So I think we have just 4 minutes. Ping me when we read this limit. So we have into 0. So it means we want to have no, 0 is not really relevant. It should be 1. So for 1, we want to set our res I minus 1. So we want to and no, like how and or something like that. And we want to have, so we have our I, we want to have I, and we want to move our pointer, so it will be like that. And we are going to set res I equals something like that. But it's still not the end. We need also do it for, so in case we have 2, it will be 2 res 2 res 2 res 2. So we are here res 0 1 2. 3 should be equals like previous value. And we are adding, yeah, we need to have another loop. It will be from 0 to I think. No, 0, yeah, to I. J plus minus minus or plus plus, let's say plus plus. So we're going to, yeah, J plus plus. All the time we are going to extend, so J. Turn res. Let's rethink about it. So we have, in terms of we have 2. So 0, 0, 0, 0, 0, 0. We want to have I equals 1 in first iteration. So J from 0, it will be only 1. It will does only 1. No, I think J will be from I to J minus minus. So in this case, yeah, so we have res 0, res 1, this one will be previous one, and we're going to mask it with ones on I. I was 1, so it will be I minus 1, I think, something like that. So we don't need to move it for first, so it will be only 1. So it will be like 1. Okay, when we have I2, I equals 2, J equals 2, so we are going to work with this one. Previous one, I equals 2, so it will be mask like 0 1 0 1 0. Yeah, previous value, no, 0 001, just 01, and we're going to mask it with this one, so it will be 3. We mark it as 3. Then I is 2, j is 2, j is 1, j equals 1, and it means we need to do it I plus j, and it will write I plus j, and here it also be, no, 1 second, j, so in case 2, j equals 2, okay, I'm out of time, it's playing with indexes, and yeah, I think we are done here. Thank you very much. Yeah. You can start with your feedback. I actually already expecting, but you still can share something.
Yeah, you will so close. We were so close to solution, but probably difficult for me to understand Java. But I can show you a solution if you're interested.
Yeah, sure. You can. I think you can share the link if you have in LeetCode or from where you get this.
Yeah.
It would be nice. I would solve it again.
Okay. Because in Python we can make a one-line solution for this.
Oh, really?
Yeah.
No, it's not interesting. But good to know. There is always some questions that it can be solved in, I know some 20 lines in Java, but 1 line in Ruby or something like that.
Yeah.
I also shared in the end of your solution a link to my question. Yeah, can you give me feedback? Something, I don't know, what you think, how it was?
Yeah.
How it was nice, to be interviewer?
It's a little bit difficult because I made mistake in description, and
it happens. We figure out we are. It's good with that we figure out it at the start. Now you know if I will. I was implemented something and then input was wrong. This was
But it was very interesting.
Cool. I wanted to give you my thoughts about how was your solution. First of all, I would like to hear discuss algorithm before we even started. So you already, when I showed you so I copied the description. So we already started to implement something. I think the best way to do it. So first of all, to explain what you're going to implement, and only then try to code it. And even better to ask interviewer, so I have this algorithm, I have this idea, do you want me to implement it? So this is one tip. Also, I think you need to work on think out loud. So every time you're writing something, try to express what you're thinking, what about you're thinking, and what you're planning to implement. It's helping interviewer to follow you, and maybe he just say, okay, so you're going to implement this one, no need, let's say we already have, let's continue and move to a more interesting part. What else I wanted to say? Yeah, so regarding the question, I think it would be great if you before express, so we are going to do this one, we have get and set, we will have like problem how to get this value and how to return it. So we are going to use dictionary, but I'm not sure how to rearrange it. I'm going to use brute force, and then you should ask, should I implement it or not? And also regarding tip, when I gave you a tip, you decided to continue with brute force. It's not a bad thing, but still I think it's better to try to understand deep what interviewer is trying to give you, and try to dive in it and try to implement it, because the most interesting thing in all this is actually after this tip, because you need to think about it. Okay, I have this note, so how can I use it? Previous, next. So the most interesting in this question was about discussion this structure. And brute force is not really interesting because you just iterating through the list. So try to listen and get maximum from interviewer, because this is when you are stuck, and this is the only way to pass through. So this is my from my perspective. I can tell that so first of all, you did good with the brute force solution. I didn't have any questions. Only thing that can help you to think out loud, try to catch deep, and discuss algorithm before. It's very helping, because it's just tip from me, from my experience, that discussing algorithm most important thing. I will explain why, because on interviewer is trying to, so he has several areas that he want to give you points. So problem solving, coding, communication, and I don't remember now, but still three most important: problem solving, coding, and communication. So try to work to think out loud. This is communication. Try to explain algorithm before coding. This is problem solving. And coding is actually coding. In coding, I didn't find any problem. So you know data structures. So I think you were good, but keep in mind these tips that I gave you.
Yeah, thank you.
Okay, cool. Let me stop share, and I think we can stop recording. Thank you everyone who watched us.